Okay, 2.1. Describe the trajectory of an object undergoing projectile motion within the Earth's gravitational field in terms of horizontal and vertical components. This is probably the beginning of, let's say, a stressful time period in space, this topic, due to projectile motion being so difficult and a concept mathematically that can be challenging as well. So let's look at the theory behind projectile motion, and we'll introduce Galileo in this meantime, but we'll start with the theory and move to the mathematics in class. So any object thrown in the air, say a ball, or at this moment of time, the water bottles half filled with water, being flipped on the desks, are a projectile. So any moving object that moves from under the force of gravity is a projectile. So anything that we throw in class, that tends to happen, is a projectile. Although at first glance, projectile motion appears quite complicated, and this is what I explained earlier, it turns out it can be analysed in terms of two simple motions that we've already studied in moving about, and this is constant vertical motion and constant acceleration. So experimentally, if two objects of the same or different masses are released from the same height and allowed to fall straight down, they'll reach the ground at the same time. And you may have watched the Brian Cox video on this in the documentary The Human Universe. However, this neglects the effects of air resistance. Okay, so this will be in a vacuum chamber with all the air pumped out. So similarly, one object falling straight down and the other object, another projected horizontally from the same height, also reach the ground at the same time. So the horizontal motion has no effect on vertical motion. So can you highlight that, please? They are independent from each other, and you can see that in the diagram there on the bottom right hand side.